All right, so this is just a little extra. It's just solving systems of equations, but it's using a method that when the systems get big, it actually it works really nicely and keeps everything organized. And when you get the hang of it, I think you'll find that it's much easier than a traditional method for doing it. So it does require using matrices, but you don't have to know anything about a matrix to be able to use this method. In fact, you don't even have to know what a matrix is. So a matrix, though, because now I'm going to tell you, all you need to know about a matrix is you can think of it as a grid of numbers. We actually call it an array, but you can think of it as a grid of numbers. So, for instance, if A, B, C, D all represent numbers, we can have a 2 by 2 matrix, A, B, C, D, and we put square brackets around the whole thing, and that magically means we have a matrix of numbers. So I'm not going to get into like what matrices can be used for and all of that. There's lots of applications for them. Programming uses them all the time. It's just a nice way of organizing stuff and then working with the numbers in there. But we're going to be organizing our numbers from our system of equations in a matrix, and we're going to be using something related to the determinant of a 2 by 2 matrix. And again, you don't even have to know what a determinant is. To find a determinant, though, of this 2 by 2 matrix, it is AD minus BC. And if you take a look, so A times D, that's the product of this diagonal, and then BC is the product of this diagonal. So you're just subtracting the product of the diagonals. Like that's all it is. So just think about that, because we're going to be using this over and over again. Diagonal minus diagonal, diagonal minus diagonal. And that's what Gauss's pivotal method does. The numbers sometimes get kind of big, so definitely feel free to pull out a calculator, but all you're going to be doing is just multiplication and subtraction with numbers over and over and over again. So I'm going to start off with an example, and we'll take a look and see how to use it to solve it. And I'm going to use the first two examples here are going to be the same two examples that we did on the previous video. So I'm going to use those same systems. Okay, so here was the first one. And so what you do, like I said, we have to put these numbers in a matrix. So we're going to put all of the coefficients of A in one column. We're going to put all the coefficients of B in another column. We're going to put all the coefficients of C in another column. And we're going to put all the constants in the last column. Some people label this with a K. I leave it blank. Just kind of depends on what you want to do. So for the first equation, then, the coefficients are 1, 1, 1, and then the constant's -2. The next equation is 4, 2, 1, with a constant of -4, and the coefficients in the last one are 9, 3, 1, and the constant is also -4. So notice that the constant does have to be on one side of the equation, and all of the variable terms have to be on the other. So you set it up like that. So there's the setup. Okay, so now what we're going to do is, now what Gauss's pivotal method does is it's really just linear combination, but a very efficient, fast way of doing it, and organized way of doing it. So what's going to happen is, remember, each line in this matrix represents an equation from above, and we're essentially going to combine two lines and eliminate a variable. And then we're going to combine two other lines and eliminate the same variable. And the variable that we eliminate is always the one in the first column. So we're going to eliminate the A's. We're going to get two equations then with just two unknowns as our result. So we're going to have two lines in the next matrix. And so I'm going to go ahead and get it set up then. So we're going to, like I said, we're going to eliminate the A's. So we're only going to have B and C left. And we're also going to get it down to two equations. So what we're going to have then is we're going to have an answer here, an answer here, an answer here. I should say number here, number here, number here, and number here. So how do we get those numbers? Well, that's where that determinant comes in. Actually, let me scroll down just a little bit. That's where this determinant comes in. We're going to pick four numbers in here, and there's a nice pattern to picking the four numbers. But to find what goes in this first box, for instance, we're going to pick 4 numbers. We're going to do this diagonal. And then to get the one below it, we're going to do another 4 numbers, and we're going to do this subtracting the diagonals and so on. So what it's going to look like is this. So just right now we're going to focus on the pattern. I'm not going to fill in any numbers. So to get that first box then, we're going to go ahead and pick those 4 numbers from the top. And we would do 1 times 2 minus 1 times 4. And that's what would go here. Then we drop down a row. But notice we're going to stay with the first row, but instead of doing the first and second, we're doing the first and the third. And that's what's going to give us a number here. So we would do 1 times 3 minus 1 times 9, and that would go here. But now we don't have any other numbers. We've hit the bottom of the row. We've hit the bottom of the row here. So now we're going to go to the C column to fill in those. So now we're going to do these 4 numbers. So notice I'm still staying over here with the A's, but now I'm coming over here. Everything always involves this upper left corner. It's called our pivot because of that. So we're going to keep this fixed, and we have to make a rectangle of numbers. So this would be 1 times 1 minus 1 times 4. That would go there. And then we drop down to the last row to fill in the last value under C. Now we've hit the last of the C's, so now we're going to go to the constant to fill in the constant column on the last matrix. So again, we're going to go ahead and start in the first 2 rows. So be 1 times negative 4 minus negative 2 times 4, and that would go here. And then we do the determinant with these 4 again. 1 times negative 4 minus negative 2 times 9, and that's what goes there. So that's the process. And we're going to fill in the numbers from that. So now I'm going to go back and actually fill in the numbers. Okay, so going back to the beginning, remember we're looking at these 4 numbers here to figure out what goes there. So the 1 times 2 is 2, 1 times 4 is 4, so 2 minus 4 is negative 2. And so that's what's going to go right there. So now to get this value, we're going to use those 4 numbers. So 3 minus 9 is negative 6, and that goes there. Now to get the value right here under C, we're going to look at those 4 numbers. So 1 minus 4 is negative 3. And now we're going to look at these 4 numbers. So 1 minus 9 is negative 8, and that's what's going to go right there. Now we're working on the last column, so we have to pick numbers from the last column. So negative 4, now this is where you got to be careful. It's easy to make silly sign mistakes. So negative 4 minus negative 8, that'd be negative 4 plus 8. So that would be 4. And then finally the last one is going to come from these 4 numbers. So negative 4 minus negative 18, that's negative 4 plus 18. That's going to be 14. And so that's the process. Now we've taken this 3 by 3 matrix, so a system of 3 equations with 3 unknowns, and relatively quickly, with very little work, we've got it down to a system of 2 equations with 2 unknowns. And then you could solve this again the traditional way, but it's actually really easy to just go ahead and use Gauss again to get it down to 1 equation with one unknown. So I'm going to scroll up here, and actually let's get rid of those. We don't need those blue. Okay, so we're going to do the same thing where we're going to pivot on this negative 2, always pivoting on the upper left corner. So that means we're going to eliminate the B's. So the last matrix that we're going to have in this problem, we're only going to have the C's left. And we're going to start off with these values right here. And so it's going to be 16 minus 18 is negative 2. And then for the last one, we're going to look at these values. We're just ready to jump over to the next column already. So let's see here. We've got negative 28 minus negative 24. So negative 28 plus 24, that's going to be negative 4. So now we have what we need to put this together. So once we have this, now remember this last matrix, that really means we have the equation negative 2c equals negative 4, so c is 2. Now we know one variable. We can go back. It's called back substitution now. You can choose either one of these lines. It doesn't matter. You pick, and I don't know, I'll just go ahead and use the first one. Remember, this means the equation negative 2b minus 3c equals 4. I'll write that down. But now we know c is 2. So if I go ahead and plug in the 2, I have minus 6. I'll add 6 onto both sides. And then we get b is negative 5. And then now we know b. Now we can go back up. And it's just like the first equation because it's just so nice. So a plus b plus c equals negative 2. But we know that b is negative 5, and we know that c is 2. So a minus 3 equals negative 2, so a is 1. And then we could go and use this in our equation, like for a sub n, like on the other video. But this is just a system of equations, so we now have the solution for a, b, c as 1, negative 5, 2. And look at the work. That's it. And the work doesn't become much more when you have one more equation. You just have one more matrix on the top, and so we're going to just back substitute one more time. That's really all it is. So I just have a few more examples just to, walk you through one more, and then the next ones are just going to be for you to try, and I'll just basically have the solutions up. Okay, so here was that 4x4 system from the other video that I said I wasn't going to solve the other way. I wanted to solve it using Gauss because it's just too messy to do the other way. I didn't even want to try it. But I'll show you how nice it is with Gauss. So if you want to try it step by step, go ahead. So pause the video and see if you can get the first matrix set up. I'll show you the first matrix and we'll see if we get the same thing. Okay, so here's the first matrix. Double check, make sure you got this. And then if you want to try getting the next matrix, if you think you got a handle on the pattern, go ahead and pause the video again. And if not, we'll do it together. So remember, the next matrix, we've eliminated the A's. Everything's going to pivot on that A, so we're going to eliminate the A column. We're only going to be left with B, C, or D. So I like to set up my matrix so I don't get too lost in there. So now let's go ahead and figure out space by space. So the first value, the first corner we're going to get is from 4 minus 8, and that's going to be negative 4. Then we drop down and we're going to do 1 times 9 minus 1 times 27, and we're going to get negative 18. And then finally for the first column we have 1 times 16 minus 1 times 64, and that's going to be negative 48. So that's the first column. Then we go over to the C column and it's 1 times 2 minus 1 times 8. So that's negative 6. Then we have 1 times 3 minus 1 times 27, and that's negative 24. And then we have 1 times 4 minus 1 times 64, and that's negative 60. And then that finishes up the C column. Now on to the D column. So now it's 1 times 1 minus 1 times 8. That's negative 7. Then 1 times 1 minus 1 times 27, and that's negative 26. And then finally 1 times 1 minus 1 times 64, and that's negative 63. And that finishes up the D column, and now just one more column to go. So 1 times 37 minus 3 times 8, That's going to be 13. Then 1 times 131 times 3 times 27, that's going to be 50. And the last spot for this matrix, 1 times 315 minus 3 times 64, and you're going to get 123. So you can see the numbers do sometimes get kind of big. Definitely pull out a calculator. So there's the next matrix. So now we're going to go on to the next one. If you want to try that one on your own, go ahead. Okay, so for the next matrix, we're going to first look at these four numbers, and when you work with them, you should get negative 12. The next four numbers will give you negative 48. Go over to the D column. You're going to get negative 22. And then you'll get negative 84. And that'll finish up the D column. Then the last one, you use those four numbers, you're going to get 34. And then those numbers will give you 132. And now you got it down to a 2 by 2 system. And at this point, if you wanted to do it a traditional way, you could. I'm going to stick with Gauss, especially since I got a calculator handy. And we're going to use those four numbers to get us the first value, which is going to be negative 48. And then those values will give us a positive 48. And now we have everything we need to find the value of the variables. Just remember, each one of these lines represents an equation. So this very bottom one means negative 48d equals 48. And very easy to see that d is negative 1. And then we can go back here and work with either one. Doesn't matter. I'll just go ahead and work with the first line. Negative 12c minus 22d equals 34. d is negative 1, so that's going to make it plus 22. And then we subtract 22 from both sides, and we're going to get, whoops, negative 12c is 12. So c is negative 1. Now I can go back to this one. I'll use the first line. We have negative 4b minus 6c minus 7d equals 13. But c and d are both negative 1. So we have negative 4b plus 6 plus 7 equals 13. Well, that looks like b is going to be 0 then. And then finally we can take all of this and go back to this first equation that says a plus b plus c plus d is equal to 3. b is 0. c was negative 1. d was negative 1. Whoops. Let me write negative 1. So we have a minus 2 equals 3. That means that a is 5. And there we go. Now we've solved it. And on the screen is all the work for solving this 4 by 4 system. I really love this method because there's no way around it. Solving a 4 by 4 system by hand is tedious. This is like the best way that you can solve it. And there's your answer right there. All right, so I'm just going to put 2 more examples up. I'm not going to do them step by step like this. I'm just going to do it matrix by matrix so you can check your work along the way. So if you want to try a couple on your own, one of them is going to be a 3 by 3 and one of them is going to be a 4 by 4. All right, so here's the first one. If you want to give it a shot on your own first, go ahead. And like I said, I'll reveal things step by step, matrix by matrix, really. All right, so that should be your first matrix. Don't forget to put the 0 placeholder for B. So double check that. And in a moment, I'll reveal the next matrix. Okay, so that should be the next step. You've eliminated the A column. Those would be your values. If you didn't get any of the values, just double check. If you're getting them all wrong, go back and check from the previous examples. But if you just got one of them wrong, just double check the arithmetic. Like I said, it's really easy to make silly mistakes on this. Okay, so the next one is going to be this. And then that's all we need. Now we're ready to go ahead and solve. So if negative 16c is 48, then c is negative 3. Go back up, we have 5b minus 3c equals 19. If c is also negative 3, then it's plus 9. So 5b is 10, b is 2. And go up to the first line, 2a minus b plus c equals negative 3. b was 2, c is negative 3. So we have 2a minus 5 equals negative 3. 2a equals 2. a is 1. And there's our solution. a, b, c is equal to 1, 2, negative 3. All right, we just have one more, and this will be a 3 by 3 system. All right, so here's the last example. So again, I'm going to reveal it matrix by matrix. So go ahead and do the first setup and then check your work with the next one. Okay, so that should have been your first matrix. So just make sure you got all the numbers right. Again, there was a placeholder. Their last equation didn't have a b, so make sure you put a 0 for b. Okay, so give a shot, give a try for the next one, and I'm going to reveal the next matrix in just a moment. Okay, so there's the next one. So double check all your numbers. And again, if you didn't get something right, just double check the arithmetic. Probably just a silly mistake. All right, the next matrix in just a moment. Okay, so there's the next one. Double check your numbers there. And definitely use a calculator. The numbers are getting quite big on this one. So there's the last one. So now it may seem like, whoa, this is not working out. But first of all, who says the numbers can't get big? But I did keep them kind of small on this. If we set up the equation, when you divide by 2,288, you're going to get that d is just simply 4. And then going back up here, 42c minus 52d is negative 250. 42c minus 208 is equal to negative 250. So then 42c is negative 42. c is negative 1. Oh, this is working out delightfully. So then I'm actually going to use the middle row because the numbers are nice and small there. Negative b minus 2c plus 3d equals 11. c was negative 1. d was 4. So we have negative b plus 14 equals 11. Negative b equals negative 3, so b is 3. And I think I'm going to go to the third line up here, the one that ends in 16. a plus b minus 3c plus 2d equals 16. So a plus b, which is 3, minus 3c, but c is negative 1. d was 4. So 6 plus 8 is 14. And a is 2. And there we go. And again, all of my work fits on one screen still. We have the original problem, I had to scroll up, but everything else fits on one screen. So a, b, c, d is equal to 2, 3, negative 1, 4. There we go. There's Gauss's pivotal method for solving systems of linear equations. Have fun with your homework. Bye.